Okay, so this is the Matlab screen, and you had an idea about the introduction, command window, script files, and so on. Okay, so let's start by the integration. If we have simple, for example, simple function, for example. So we can directly find the exact integration by using the function. Sorry, I will start with the differentiation. Sorry. So let's start by making the variable x as a symbolic form. So if you make SYMS x or sims x, MATLAB will directly understand that you need to write a function with respect to x. So first of all, you can start by typing sims x. Then you can type, for example, you give them the function f of x equals to x square minus 1. Okay, so now MATLAB, even though MATLAB sees that x does not have an exact value, for example 4 or 1, however, it knows that x is a symbolic value or symbolic variable. Okay, now you can say, for example, def f of x. So this will give you the first derivative of function x square minus 1. You can try it and you can use any other function. For example, g of x equals to sine x. Now you can find def, for example, g of x. Okay, so now this gives you the exact function, exact derivative of function, any function. Okay. Now, if you have polynomial function, something like x square minus 1. Usually, polynomials can be entered in MATLAB in the following form. So, p equals to, if you are talking about x plus 1, not x square minus plus 1, so x plus 1, so it will be, or x square minus 1. Now this will be something like this. P equals to x square, so x square is 1. Now in this form we are entering the constants multiplied by the polynomial. So x square minus 1 will be 1 multiplied by x square plus 0 multiplied by x minus 1 multiplied by x0. So 1 is the constant multiplied by x square. Okay, now 0 is the constant multiplied by x, and minus 1 is the constant multiplied by x0, or it is the free term. Okay, so this is a polynomial. Now you can use function called polyter. So for example, a equals to okay. Yes, polyter of b. So now you had the first derivative as a equals 2 and 0. This 2 and 0 means that 2 is the term multiplied by x, so it is 2x. So if you have, or if you, as you have seen here, If you differentiate x squared minus 1, it will be 2x. So polyder function gave you 2 and 0, which means that it is 2x plus 0. So it is 2x. Okay, these are the, for example, if you have another function, for example, I will call it P1 equals to 1 and 1. Okay, and P2 equals to 2, 3, and 5, for example. And you need to find the derivative of P1 multiplied by P2. And this is common. Usually, if you do this manually, you have to use the derivative or the multiplication of two derivative of two multiplied polynomials. So either you multiply the first polynomial with the other, then you find the derivative, or you use the rule which says that f1 prime multiplied by f2 plus f2 multiplied by f1 prime, if you remember this rule. So you just use a command called convolute. Conv. Okay. Conv means that I need to multiply these two together. Let me call this P3, for example. This should be equals to convolute P1 and P2. So this means polynomial 1 will be multiplied by polynomial 2 and stored in the variable P3. Then you can find polyder for P3. This is the case if you need to find the exact derivative. Okay, using the def function. You can have more information about the def function by pressing or by using or asking Matlab to show you the help of the def function. So all of these are the def function help. Okay, def x for a vector x is x2 minus x1, x3 minus x2 وهكذا. So this is the derivative. Okay, so now this is the exact. Let's make an example of this function. Let's take a function x cubed plus 2x squared minus x plus 3. So f x equals to x cubed plus 2x squared minus x plus 3. Yes, okay. Okay, now let's find the derivative of fx. Okay, so it is 3x squared plus 4x minus 1. So let's store this. Please write it down. I'll write it down in a certain paper here. 3x squared plus 4x minus 1. So this is the derivative, and the function is x cubed plus 2x squared minus x plus 3. This is the function. Now let's try to make or to show you how can you numerically differentiate this equation or this function. Okay, So let me now show you how can you find the derivative. Okay. Now you need to open a new script file. Okay. So let's open a new script file. And let's start by defining the value of x, for example. Okay. So let's define the value of x to be something like x equals to minus 10 with an increment of, let's make it 0.5 up to 10. Okay. Now we need to make the integration numerically. Okay. Type. Now let's write the value of y, which is fx, the same as this value. So let me copy this value here. However, there is a problem here, which is now x is not a symbolic function, it is an array. Okay, so we need, in order to do this operation for the matrix, so it's basically a matrix. In order to do this operation for a matrix, you should put the dot. Dot means that you need to make the operation for the matrix. Now, if you don't put the dot, you will get error. Okay? There is no operation here, so there is no need for the dot. Okay, so this is the function f of x. We call it y here. Okay, now the exact derivative dy dx exact equals to this value. Correct? So we can copy this value here, and we need to put the dot here and here. Now what I'm going to do is to find the exact derivative and find the numerical derivative and compare them to each other. Okay, so far we defined the value of x from minus 10 to 10 with an increment of half. Now we did this before and we already found the exact derivative. Okay, so we put the exact derivative here, and this is the function x cubed plus 2x squared minus x plus 3. Okay, now we need to do the numerical derivative. Simply, the derivative is defined as dy over dx, correct? Yeah. So we can simply write dy equals to def y and dx equals to def x. Tamam? And dy dx, the numerical, I just added num here. Okay, and I added exact here. So these are the derivatives. This is the numerical, the exact derivative, and this is the numerical derivative. Okay, equals to dy over dx. However, as we said, now dy, these are vectors or matrices, so you have to put the dot. Okay. Now let me plot them together. Plot them together and check what's the how they compare to each other, or how exact or how accurate is our numerical derivative if you compare it to the exact derivative. Okay, so let me plot x with dy dx exact. Okay, and x dy dx numerical. Let me now add a legend for the plot. So the first one will be the exact derivative. This is the legend. The second one will be the numerical derivative. Okay. Now let me add labels to the x and y axis. X label and y label. Let me add title for this graph. Title, I will call it, for example, figure 1. And let me add some grid. طيب, so this need to be saved. I will press on run. I prepared a folder for you for level 2, so let me save it in the right folder. Level 2. So I will call it EX1, example 1. Line 5, let me go to line 5. Okay, so let's see what's the problem here. I will write it again. Exact equals to 3 multiplied by, because I copied this, I did not trust it actually, x dot 2, correct, plus 4 multiplied by x minus 1. Okay, here, no need for this. Okay, x dy dx, yes. Now we have a problem here. Vectors must be at the same length. Okay, now if you go back to the definition of the derivative, it always gets a value of x minus, for example, dx or dy equals to y2 minus y1. Now, if you look at the value here, dy dx numerical, so it is dy by dx. However, dy, once it reaches the end, it should take another, for example, you start at 10 and you minus 10 and you finish at 10. Now at this point, dy, in order to be calculated, should take another value after 10. So this means that the operation of def, or this def here, it gives you one variable or one entry short from the value of y itself. Okay, for example, if the vector y, if you look at vector y, assume that, for example, it may be 5 entries, 1 2 3 4 5. Now once you differentiate it using def y, it will be 4 entries, not 5 entries. So it will be, for example, 3 2 5 6. This is why we have to make a simple trick and write dy equals to, oh, not dy, dy dx numerical equals to, okay, dy dx in numerical, any number, none. Okay, by this we added an entry for dx, dy dx numerical. Okay, so when Matlab goes to the plot, he will find out that all of them have the same size. So if this is like 10 entries, this will be 10 entries, this will be 10 entries, this will be 10 entries. Without this, if you remove this, when Matlab goes to the plot command, this will be 10 entries, this will be 10 entries, this will be 10, and this will be 9. Okay, because this is the nature of the def function. It gives you one vector short of the original variable. Okay, so let's press on run now. Wait for the graph. Okay, can you see the graph? Can you see my screen now?
Yes, we can, Doctor.
Can you see the graph?
Yes.
Okay, I don't know which screen you can see now, because Teams always give plenty of screens. Okay, so this is the graph. If you look at the graph, you see that the red line is the numerical derivative, while the blue line is the exact derivative. And there is some distance between them, or there is a little error between them. So this error or this deviation depends on the increment that you are using here. So let me show you, for example. I will close this. Let me increase this increment to 1, for example, and run it again. Okay, so now as you can see, the increment or the difference between the exact and the numerical derivative is larger. Correct? So let's make it at 2, for example. Now you can see that it is also larger. So what we need to do is to decrease the increment as much as we can. So let's make it like, instead of it was 1.1, let's make it 0.1 and see what happens. Okay, so if you look to the graph now, you will see that it is very close to each other. Okay, if you need it to be more accurate, you can add 0, for example, and you see that you will get only one line. See, both of them are at the same line. So this depends on the increment that you are using. Okay, now you can, now here for x, you can use any function. Let's try this with sine x. I will try this. This is sine. The derivative of the sine is cosine x. Okay, so now let me change this from minus pi pi over 8, for example, up to pi. Okay, Now I think we will have a problem here. I don't know if this works. We will try. I will remove it. Let's see what happens. Okay. So this is the exact derivative and this is the numerical derivative. This is the cosine function. Now, if you need to increase the accuracy, you can make this, for example, 16 and plot it again. Okay, so you have better accuracy now. However, you can also increase it a little bit. You can make it 32, you can make it whatever increment you like, based on your application. Okay. Guys, are you there?
Yes, they are there.
Yes.
But if you want us to unmute them so they can participate, we can.
Yes. So please, I don't know who's responsible for the chat questions. If there is any questions on the chat box, please send them to me directly, okay?
Okay, there is a question.
Yes.
Iman asked how to apply the def function if we don't have symbolic tool in our Matlab.
See, Iman, we don't have, there is always symbolic tool. There is always sims x. And it comes by default with Matlab. However, if you look here, we are not using the symbolic function here. We are using a vector of x. Okay, we are doing this numerically. So we are not using sims x, we are using a vector x. So let me show you what's the value of x here. All these are values of x. It starts from minus pi, this is minus pi, up to pi. Okay, so def works for a vector and it works also for symbolic variables. Okay, let me add one more thing here, and you will also, I will show you how to do subplots as well in the same example. So subplots in Matlab, it means that you need to make one or more than one graph at the same plot. Okay. Okay, can you see my screen now?
Yes, we can.
Okay, so I will make the y in a plot, and beside that plot I will make the derivatives on another plot. So here, after I finished here, okay, so I can make the subplot. I will do it here. Subplot. Now, I need to select the number of rows, the number of columns of the plot, and the number of plots. So I need to make one row, two columns, and I will select the first figure or the first subplot. So 1, 2, 1. Okay, so it is 1, 2, 1. Subplot 1, 2, 1. Okay. Now I will plot X and Y. I will add the legend here. Okay. Now I need another subplot. And this subplot will be 1, 2, and 2, which is the second figure. See, both of them are 1, 2. This is the property of the plots. 1, 2 means one row, and I need two plots or two columns beside each other. Now for the first one, I will select subplot 1, which means that it is the first figure, and 2 is the second figure. Okay. So now this should be not y, this should be dy over dx. This is correct. I will remove this. I will add a grid here as well. Okay. Let's wait for the graph or the figure. Okay, so this is the figure. On the first figure is sine x. The second figure is the derivative of sine x, which is cosine x. So this is how you make subplots in Matlab. Okay, now if you add, for example, 2 here and 2 here, you will have 4 plots, but 2 of them are empty. Okay, so this is some empty space here. You can add plots here and here. Okay, so if you select 2, 2, and 1, this is the first one, this is the second one. Now this one will be 2, 2, and 1, and this one will be 2, 2, 2. Okay. Any questions so far?
Guys, if you have any question, just raise your hand so we can unmute you.
Type. So what if you have something like this? I need to switch to the whiteboard. 1 minute, give me 1 minute. Okay, so what if you have something like this, huh? What can you see now? Can you see my whiteboard?
No, we can't. We see a black screen. Now, yes.
Can you see my whiteboard now?
It's loading, yes.
Okay, so what if you have, for example, function with x and y? Like, for example, z of x and y equals to x divided by e to the power x square plus y square. You can see my okay, I'll try to share it again. I dismiss. Okay, can you see it now?
Yes.
Function f of x and y, and we need to do the derivative. Okay, so we have the function. We will solve this. z of x and y equals to x divided by e to the power x square plus y square. Okay, so let's try to solve this and see how we can solve it. We have to use new commands. One of them is gradient and one of them is quiver. So let's see how can we do this. I will go back to Matlab now. This is the Matlab. Okay. Let me start or open a new script file. 1 minute. Okay. I will start by okay. Now I need to start by defining a value of h. And this h, I will show you what does it mean. You can select any value for now, but it depends on the application or on the result you need. Now I will define x and y as mesh grid from -1 with an increment of h up to 1. This means, okay, this means that I have defined the, let's say, the plot at the beginning to start with from -1 to 1 with an increment of 0.1. Okay. Now I can write the value of z as, okay, don't forget that I have already defined x and y. X and y are all the values from -1 to 1 with an increment of 0.1. So x and y are all these points that are bounded between -1 and 1. Okay, so z equals to x dot divided by exponential, and I am adding x dot because it is a vector now, x is a vector now, plus y dot square. Now I can use something called gradient. Gradient is like the derivative. So I will call it, for example, gx for x and gy equals to gradient z and h. Now I need to make the contours, because as you know, this will not be a simple plot. It will be a contour plot. Like, for example, if you have x plus, if you can define z equals to x squared plus y squared, this will be a circle. So in order to do this in 2D, you have to make it as a contour plot. So I need to ask for the contour of x, y, and z. Now, hold on, because I am not finished yet. Now, for the contour, I need to define the arrows that goes from point x and y to the direction of the z, or the direction of, let's say, derivative. So this is called quiver. Function is called the quiver, x, y, gx, and gy. Okay, so let's try it now. We define the value. See, if you have a vector 1D, for example, you define x equals to مثلا -1 to h to 1. However, if you have x and y, you have to define the mesh grid. Okay. Type. So let me start this. Again, I will take it to the folder. MATLAB workshop level 2. Okay, so let's see what the problem. Line 4, line 4. Okay, line 4. This should be. Okay, so if you look at this graph, these are the contours, the lines are the contours, and the arrows are the quivers, or the direction of starts from x and y into the direction of u and v, which are gx and gy. Okay, so any one of these arrows, it starts from x and y. So this is x and this is y, and it goes into the direction of gx and gy. Okay, so this is the derivative of our function, or this is the plot of the derivative of our function. So if you change it back, I will make it here. Okay, so this is x squared plus y squared. You should get something like a circle now. Okay, so this is the circle, or circles. It depends on the value from -1 to 1. واضح؟
Yes, Dr. Shamma asks, she doesn't totally understand what's the function of quiver.
Okay. Okay, I will remove the quiver function. And let's see how the graph now. So this is the graph. Okay, these are the contours. These are the contours of Z. Contours of X, Y, and Z. Now the quiver is the derivative. Quiver shows you the direction of the derivative. So actually, quiver, the arrows itself. Let me just, okay, once it's opened, okay. See, the arrows itself are scaled based on the size of the figure and size of the let's say value, minimum and maximum value. Okay, so this is the, now for quiver, if you need to understand it, basically it is the beginning of the arrow is the value of x and y. The direction of the arrow is gx and gy. Go back to gx and gy. The direction is the gradient. Okay, so the direction of the arrows are, for x, the direction of x and direction of y. So it will be in 2D. So for example, this is the point. Now it goes in the x direction, it take it in this direction, and the y direction raise it up a little bit, so it will be in this direction. واضح؟ طيب, so what do we have else in the integration? I think that's all. Let's make this, because I have some examples. If you make this, for example, instead of x, sine x, and let's see how does it. So let's make dot, for example, see what happens. Okay, so it's here, the figure is here. Okay, so this is the derivative of sine x divided by e to the power x plus e to the power x square plus y square. Contours and quivers. The actual derivative is the gradient. So if I remove this, yes, if I remove this, you can go to gx and gy. These are the gradients. So go back here. This is gy. So it gives you the derivative at each point from -1 to 1. Okay, while gx is here, this is the value of gx. Okay, now what we did here is we represented them graphically. Okay. Okay. طيب. Do you have any questions regarding the integration? And I cannot, of course, I cannot give you everything, but I can give you keys so you can help yourself in يعني acquiring more knowledge in Matlab. طيب, let's go back here. Okay, and let's start with the integration. So if you have, for example, a symbolic variable of x, and f of x can be defined as, for example, x square minus 1. Now you can define q equals to int f. So this will integrate the value, or this will integrate the function x square minus 1. So in the differentiation, it was def. Here it is int for integrate. Okay. Yes. Allah, give me 1 minute, please. 1 minute, please. Okay. Now, let's go back again and define them, the polynomials, as, for example, P1 equals to x square minus 1. So this will be x square, this is 1, 0, minus 1. Okay. Now we can use the function polyend. In the differentiation, when you define the polynomial in this form, we use polydar. Here we use polyend. So I can say that, for example, polyend P1. So you will get, this is the, if you look at this, it will be the same as this one. Okay, so there it is polydar, here it is polyend. You can also make the convolution, and for example, P2 equals to 1, 0, 1. And make the convolute of P1 and P2. Then find, again, I can call this P4, for example, and find polyend for P4. Yes. Okay, so this is how you deal with the exact integration of polynomial, and using the symbolic function simsx, you can find any integration you like. Now, what about if you need to make numerical integration? Sometimes you have to make numerical integration. Let me switch back to the my whiteboard to show you how can we do this. Can you see my whiteboard now?
Yes, we can.
Okay. And we know that the integration is simply the area under the curve. So if this is y and this is x, the integration is the area under the curve. So usually, and you know this before, usually we take very small areas called dx dy. So this will be dx. Okay. Let me take this area. Okay. Here and magnify it or zoom a little bit. So it will be something like this. Correct? So this is one area. What we need to do is to find this area and to find all these areas, small areas, and add them together. Correct? Now for this area, this will be x node and this will be x1. This will be y node and this will be y1. Correct? Okay. So what's the area of this trapezoidal shape? What is the area of this trapezoidal shape? Simply area equals to y naught multiplied by x1 minus x naught plus, this is the first area, correct? So it is y naught height multiplied by x1 minus x naught, which is delta x. So this can be written as delta x. Plus the area of this small triangle. So this is y1 minus y naught, and this is still delta x. So it is half delta x multiplied by y1 minus y2. أو بلاش y1 minus y2. This is y1 minus y naught. Okay. Now I will remove this and write delta x instead. So this is delta x. If you take delta x as common, it will be delta x multiplied by y naught, correct? Plus half y1 minus half y naught, correct? So again, this is a equals to delta x multiplied by y naught plus, this is y1 minus y naught. If you take half as common, so this will be y1 minus y naught divided by 2. Correct? طيب. Now delta x in Matlab, we can define it as def x. And y1 minus y naught in Matlab can be defined as def y. Okay, so we make use of these two in order to find the value of a. And finally, a will be a total, will be summation of delta x multiplied by, or summation of this. A total will be summation of this term. واضح؟ طيب. Let's go back to Matlab and see how can we use this, or how can we write a code to reflect this. This is called the trapezoidal rule. Trapezoidal rule. Okay. Let's try to write a code to reflect this understanding. Let's go back to Matlab. And now, okay. Let's try to do the numerical integration. First of all, we need to define x. So we can define x, for example, x equals to 0, increment 0.1 up to 4. It's up to you now. This is an example. Now, I can say, for example, I need to find the numerical differentiation for y equals to x squared minus 1. So this will be x this is my function, x squared minus 1, correct. Now, let me plot this function first. Now, let me find dx, which is def of x. And let me find dy equals to def of y. Correct? Now, I will define something called y average. Okay. Which is equal to y from the first entry up to the last entry minus 1. Remember what we said about the differentiation? Integration is the opposite. So there you have to add one entry. Here you have to, there you have to add one entry. Here you have to remove one entry. Okay. Plus dy over 2. Let me show you what does this mean here. Now, if you have a certain array, for example, a equals to a simple array 2, 4, 5, 6. Okay, we can define another array. I need to define another array, but it should take, for example, from 2 to 4. Yani part of A, not all of A, from 2 to 4 or from 2 to 5. So if you define the Q equals to A from the first entry to length of A, you will have Q equals to A. Now, if you define the Q up to length of A minus 1, it will be up to entry 5 or up to the entry, the third entry, because they are 4, so minus 1 is 3. Correct? Now, if you define it again, minus 2, it will be only 2 and 4. So you are selecting the entries, okay, not the values. So here I need to make the y average from 1 up to the length of y minus 1 plus dy over 2. This is what we have just showed you on the whiteboard. Now we need to find the total area is sum of all y averages multiplied by dx. Okay? Very good. So let's run this. I would save it in the folder. Okay, so area equals to 17.34. So what I did is I defined or I integrated over this period from 0 to 4. Okay, I integrated x squared minus 1 from 0 to 4. Now this increment, it gives you a little bit, or it can control the accuracy. So it was 17.34, now it is 17.36. Let me put, I will suppress this and I will leave this. So in the first case, if you have 0.2, it will be 17.36. If you decrease the increment a little bit, it can be more accurate. 17.34. So now it is 17.3334. So what if you need to change the boundaries of integration? You play here. So this can be the boundaries from 1 to 10. You are integrating from 1 to 10. So this is your final value of area, or your integration will be in this form. واضح طبعا. I made a plot, so this is the plot of okay, I need to close it and run it again. Okay, so this is your plot. And this is your area under the curve. Okay, now if you put it from 1 to 4, you are changing the boundaries of integration. So check, now this is the area under this curve. Okay. واضح? Any questions? Can you check the chat box if there is any questions?
No question.
Okay, very good. Very good. Right. Now, integration, it's not only done using, or numerically done using the trapezoidal rule. There is some built-in function for numerical integration, built-in function in Matlab for numerical integration. I will talk about two. The first one is the Simpson quadrature rule. Okay, Simpson quadrature rule. Okay. However, this function, they need to something maybe you don't know so far, but I'll show you how to do it. First of all, if you need to use these two rules, the first one is Simpson quadrature, and the second one is Lobato quadrature. Lobato quadrature. Maybe the name is, you feel it is difficult, but you will see that it is very simple. Forget about the names now. Let's define a function here in the script file, and I will call it my function. So I will define a function. A function. I will call it y equals to my fun. Okay, and it is a function of x. Now I can define, for example, any function you like. So I can say y equals to sine x. Any example you like, you can do it. Okay. Now we need to save it. So I will save it in the same folder since I added the folder to the path. I will go to my MATLAB workshop level 2. It's called my fun خلاص. Okay, so I have now this function. Now I can go to the I can make another script file, or you can go to the workspace. Let me increase the size here a little bit. Now I can define x to be 0 with an increment of 0.1 up to pi. Okay, I can press enter and I can suppress, so I will suppress. So it will not take a large space. Okay, now I can define, or I can recall y equals to my fun of x. Okay, so this is y. Now I can use the rule or the numerical integration method, the Simpson quadrature. A equals to quad, okay, at my fun اللي هو الفانكشن اللي عرفناه 0 pi, from 0 to pi. So this is the value of A. Let me suppress here. Okay, so this is y, and this is the value of the integration. So if you make the integration, you will get integration of sine x from 0 to pi equals to 2. From 0 to pi, احنا سويناه from 0 to pi, yes. So integration, if you do it manually, you will find that it is equal to 2. Now the second rule, or the second method for numerical integration, it's called the Loboto quadrature. We do it like this. I will call this A1. You just add 1 here, quad 1. Okay. Should be quad L, sorry, quad L. Quad L, Loboto, yes, quad L. I'm sorry. So again, you will get 2, which is the same value. Now, if there is any difference, it will be here. So we defined x. I will define x another time. So I will make it 0.5. And let's see what happens if you increase. So it is still 2. I can use quad L. Again, it is also 2. So both of them are giving the same answer. However, the number of increments is now 5. So you have 5 entries. And there at the first time we have from 0 to pi with an increment of 0.1. It gives you 13 entries. Okay, so the functions are called quad and quad L. Quad for Simpson quadrature and quad L for Loboto quadrature. Okay, now here we just define the function. We just define the function y equals to sine x using the function command. Okay. Is there any questions so far?
Guys, if you have just raise your hand. There is no doctor in the chat.
Okay, very good. Right. So now I think integration and differentiation, it's basics. So let's try to use this knowledge in solving differential equations. We will focus on initial conditions differential equations. Okay. Type. I will start sharing from my whiteboard. Where is the whiteboard here? Whiteboard. This is Matlab. Okay, it seems. Okay, I will try to do it again. This is the whiteboard. Very good. Okay. Now, in order to make the most commonly used function for finding or for solving the differential equation is they are three functions. One of them is ODE23, one of them is ODE45, and one of them is ODE, I think 113. I'm not sure, but now usually we use this one, ODE45, and I'll show you how to use it. Okay, this is called low ODE23. It is okay. I will tell you what they stand for. ODE23 is third stage Runge-Kutta method. So this is third. It is the third stage. '45 is the fifth. I think it is fifth stage. Sixth stage Runge-Kutta method. Now I am not using 113. Okay, usually I use ODE45, and in mechanical engineering, most of our cases will rely here in ODE45. So first of all, how can we use the toolbox of ODE45 or the function of ODE45? أول شيء, first step, we have to rewrite the differential equation in state variable form. What do you mean by state variable form? If you have studied engineering analysis, or now it's called advanced engineering, you know that differential equations can be written in a state variable form, something like this. So x dot as a vector equals to a multiplied by x, okay, plus b, or constant vector. So this is the coefficient matrix, and students who are studying advanced engineering mathematics with me and Professor Kamal now know that if b equals to 0, this will be homogeneous system. If b is not equal to 0, it will be non-homogeneous system. Okay, so what's the value of x dot vector and x vector? So x dot vector is simply x1 dot, x2 dot, x3 dot, for example. And x vector equals to x1, x2, and x3. Okay? And this is equal to x1 is x, x2 is the first derivative, x3 is the second derivative, وهكذا. Okay? Now this means, by definition, if x dot equals to x1 dot here, so x dot equals to dx by dt by dt square and correct? Time. So if you look here, you will see that x2 equals to dx by dt. However, dx by dt equals to x1. So we can say that x1 dot equals to dx by dt and equals to x2. Correct? We also can say that x2 dot equals to d square x by dt square. It can be written as x3 if you have more, for example, third order, fourth order, وهكذا. So, which is equal to x2 dot, correct? d square x by dt square equals to x2, correct? Type. So if you have, for example, a differential equation, let's say that you have a differential equation in this form. Let's take an example. D square x over dt square plus 7 dx over dt plus 10x equals to 20. We will solve this differential equation using ODE 45. Now I have initial conditions x of 0 equals to 5 and x dot of 0 equals to 3. So let me start by writing this differential equation. This is second order ODE. Let me start by writing this differential equation in state variable form. Okay? So, d square x over dt square equals to 20 minus 7 dx over dt, correct? Minus 10x. تمام. الآن we said earlier that x, we have only second order, so x equals to x1 and x2. Okay, and this is equal to x and dx over dt. Type. And we said also that x1 dot equals to dx1 over dt. x1 dot هي عبارة عن dx over dt, correct? اللي هي نفسها dx over dt وتساوي x2. طيب x2 dot equals to d square x over dt square, correct? So simply I can write this equation in a state variable form by writing x2 dot. This will be dx by dt square, so this can be written as x2 dot. And dx by dt can be written as x2, correct? And x, what is x? X is here, so x can be written as x1. This is x. So I can write this as x2 dot equals to 20 minus 7 multiplied by x2 minus 10x1. واضح؟ If you write the differential equation in a state variable form, you have done most of the work. يعني more than half of the work is done. Okay, now you just need to define x2 dot and x1 and x2. واضح? Let's go back to Matlab and see how can we do this. Okay. Any questions about the state variable form? Okay, so I will start sharing from Matlab now. I will make a new script file. This is a new script file. Now I need to define a function called x dot. Oh, for x dot. Type. So this is a new script file. I will call it 1 minute. Function x dot equals to, I already used my function, so I will call this func, okay? And it is in t and x. It's a function of t and x. Now, x dot 1 was defined as x2. Okay. Now, x dot 2 is defined as the differential equation 20 minus 7 multiplied by x2 minus 10 multiplied by x1, correct? 20 minus 7 x2 10. And we'll do something, okay? X dot equals to x dot transpose. Okay, why did we do this? You will find out later once we do the ODE 45 that x dot needs to be a vector, okay, not array. So this is array, it should be a vector. We just converted from array into vector, so it is a transpose, only transpose. Yani if x dot was 1, 2, 3, 4 as an array, now it will be from horizontal array into vertical vector. Okay, so again I will check function x dot function t of x dot 1 equals to x2, x dot 2 equals to 20 minus 7 x2, exactly. So what we have written here is what we have just did on the whiteboard. We defined x dot equals to x2 and x dot 2 equals to the differential equation to the right. So we just played with the variable name, okay, to be as per the state variable form. So let me save this again. Level 2. You should save it at the same function name. You should not change the file name. Okay, so you can recall it back in another file or in the same workspace. Okay. Type. So let me now define another script file. Okay, to use the ODE 45. أول إشي I need to define t and x equals to ODE 45 for the differential equation or for the function that I have just func. We call it func, correct? Now you use the boundary condition, initial conditions at 0 y x, يعني if you go back to the initial condition, you have 0 and 5 and 0 and 3. So this is 0, 5, 0, 3. I'll tell you now what is meant by this boundary condition. Now we said that x of 0 equals to 5. So the first one is x. I represent the boundary conditions, the initial conditions here. X of 0 equals to 5 and x dot of 0 equals to 3. Okay, so this is how you write or use the ODE 45. تمام. Now I need to plot, for example, E and x. However, x will be plot t and x up to the last entry. Now I need to hold on and I need to plot again. Okay, x2. The first one was x1 and now this is x2. Now I need to, for example, add a label, y label, time, x label, for example, and I need to add a grid. You can add the figure number, you can add legend, whatever you like. Okay, so now let's run this. Store it at the same location. So I have EX5. EX5 is vacant. Okay, so this is the solution. Let me add the legend. I should have added a legend. Okay, I will add a legend so you will understand which is which. Okay, so after the plot here, y label, I will add legend. Okay, the first one is x e, and the second one is x dot okay. Legend. Okay, so let me press now here. Okay, I'll do it again so we will not okay, so this is our solution. Now the first one, x of t, and the second one is x dot of t. So as you can see, ODE 45 solved the differential equation from 0 up to 5. Okay, because this is the range from 0 to 5 and from 0 to 3, who depends on the boundary conditions. Now plot t x1. So this is the first plot, t with the first derivative, which is x of t, and the second derivative is for x dot, or the second plot is for x dot. So the red line is for x dot, and the solution, your solution x of t, is the blue line. Okay. Legend, we added legend and grid. So this is how we use the ODE 45 toolbox, let's say, or solver. It's called ODE 45 solver. Okay. Type. So based on this, you can you can solve any initial conditions or initial value problem, or as you call it, initial conditions boundary differential equation. واضح? So you can, if you need to change the function or the value here, you go back and you define. So this is common. So this is common for any differential equation. You just need to play with the boundary conditions here or initial conditions here. Okay. However, this can be changed in order to solve another differential equation. So you keep this file, we call it ex5. You keep it. This is how you solve it. This is the solver. So this is the code for any differential equation. You just play with the bound or initial conditions, and here you change the differential equation from here. This one will be common. If you have second order differential equation, it will be always in this form. So you can play with the differential equation here. You can make this, okay, it's freezing. You can make it like this, for example. Okay, then you can save here and go back to the solver and press on run. Now you will have new graphs. Okay, so a new solution. واضح? So if you need to, yes.
Khalifa has a question.
Yes.
Okay, come on.
السلام عليكم دكتور.
السلام عليك خليفة.
كيف الحال؟ دكتور عندي سؤال بسيط بس الحين 0.5 و 0.3 هذول مشينا الانيشال كونديشن حق المسألة؟
يس.
زين الحين شو معناه بالضبط؟ يعني ما اتذكر شو كان مكتوب في البورد. هل معناته انه يعني شو معنى الزيرو وشو معنى الفايف؟ انا هذا اللي ما فهمته.
اوكي هلا عشان تحل اي initial value problem هي اسمها initial value problem. اذا كانت first order you need only one initial conditions.
اوكي.
اللي هو بيكون مثلا x of 0 equals to something. اذا كانت second order you need two initial conditions. You need x of 0 equals to 3 and x dot of 0 equals to something. إذا كانت third order you need. ليش موجودات؟ ليش بدنا إياهم هذول؟ عشان أنت عارف إنه في النهاية it's an integration. يعني إذا عندك أنت very simple differential equation وبدك تعملها integration حيطلع معك integration constant اللي هو c صح؟ إذا كانت first order. إذا كانت second order حيطلع معك C1 حيطلع معك C2. إذا كانت third order لأنك بدك تعمل integration 3 مرات أو مرتين. إذا كانت third order بدك تعمل integration 3 مرات فبيطلع عندك C1 و C2 و C3 هم ال constant of integration. فكيف نطلع ال value of constant of integrations في العادة using the initial conditions أو إذا كان عندك boundary value problem using the boundary conditions.
زين دكتور الحين الكونديشن الاول حق دوت صح والكونديشن الثاني حق تو دوت.
الاول تبع الاكس والثاني تبع الاكس دوت.
اوكي بس جزاك الله يا دكتور.
هاي معناها x 0 equals to 5 وهاي معناها x 0 x دوت 0 equals to 3.
ايوه واضحه دكتور جزاك الله خير.
اوكي good. طيب بس عشان نكون واضحين الآن بإمكانك أنت شو تسوي عشان تسهل على حالك الأمور. تعمل السكريبت فايل هذا وهذا اللي حيتغير عندك. هذا اللي ممكن تعدل عليه. أوكي السكريبت فايل الثاني هذا بس بتعدل عليه إيش الانيشال كونديشنز. then you can solve any problem. واضح؟ طبعا any problem second order. if you have third order بدك ترجع تعدل هون وتحط x دوت 3 مثلا. واضح؟ او هاي حتصير x دوت 3 والها علاقه ب x2 و x1 و x3 ممكن. عرفتوا كيف؟ if you have third order differential